So media access control layer is your second layer, which is a sub-layer of your data link layer. As we all know, to transfer any information from one node to the another, in practice we are making use of TCP/IP, which is of file layer of processing the information to get transferred from one end to another end. Here also, for this domain, wireless sensor network domain, we are going to make use of the same set of 5 layers, but the protocols may vary depending on the domain we are making use of, based on the requirements of the domain. Okay, so here, since the syllabus is confined to the second layer, and mainly to be more specific, the second sub layer, media access control layer. So before moving into the MAC layer, first we will see. So here the functions of MAC layer. As you all know, it provides address resolution, multiple access resolution, collision resolution, and protection against the transmission errors. So error, flow control, and access control, as well as the address resolution, is also taken care in your MAC layer, as like your logical control layer of your data link layer. Okay. So before designing any protocols for wireless sensor network, specifically under a MAC layer, we looking for certain requirements. As we looking for certain requirements has to be satisfied. Traditionally speaking, we looking for throughput efficiency, stability of the network, fairness, low access delay, like the time between the packet arrival and the first attempt to transmit it, and low transmission delay. It's nothing but the time between packet arrival and successful delivery, as well as the low overhead, because of extra control packets while exchanging the information also could cause collisions. So that we put it under low overhead. So as I told you before itself, while designing MAC protocols, the first and foremost requirement we looking for, traditionally other than these requirements, now collisions. So the first factor which would contribute for collision is low overhead. Other than this, now see, suppose two or more nodes tries to send packets at the same time in a shared medium, now we may face a collision. Or sometimes because of the inability of the receiver to decode a packet correctly, so it will cause a delay, causing the upper layers to perform a retransmission. So these are the three general factors contribute for collisions. Specifically speaking, when it comes to WSN, there are other two more problems which has to be taken into account while designing. Those two problems are hidden terminal problem and exposed terminal problem. So here is a scenario. We have brought 4 nodes for an example to explain the scenario. Few authors named this problem as hidden station problem or hidden terminal scenario problem. So here I have named it as hidden terminal scenario. So here I have taken 4 nodes. These circles indicates the transmission range of each and every node, having the node at the center. So this is for A, B, C and D. And when we look at the picture, it is very evident that B is within the range of A. So whatever happens to B and A, both knows mutually, because both are neighbor. And similarly, whatever happens between C and D, or even if any one does a transmission reception, both are aware of that, because they are both within the range of transmissions. And when it comes to B and C, yes, between B and C also, as a neighbor, they are aware of each and everybody, what is happening around. But A is not aware of D, what is happening to D. Okay, because D is not within the range of A. Also C is also not within the range of A. So when A tries to send a packet to anybody, say suppose A tries to send a packet to B, because that is within the range now. C doesn't know about this, as well the D also. Say suppose at the same time C is also trying to send a packet first both A and C, whomever wants to send a packet now, they will sense the medium first, whether within the transmission medium any information is being, any transmission or reception is happening, or is the medium, is the space is busy or not. So this protocol who is making the device to send sonar, that we call it as carrier sense multiple access protocol. So CSMA carrier sense multiple access protocol will help any node to sense the what is happening to the neighboring nodes within the range. So first, say suppose A wants to send a packet to B, a CSMA is applied. So it comes to know that B is idle, so it is free to send. At the same time, C also does senses, like tries to sense CSMA. With the help of CSMA, it tries to sense to its knowledge, because A is not within the range of C. To its knowledge, B is idle. So both A and C tries to send the information to B, which is in the range of mutual range of both A and C. Since it is hidden in the range of A and C, both try to send the packets at the same time and end up with a collision. So because of this protocol, because CSMA is designed for wired transmission at the earlier days, they tried to apply it for wireless communication also, because as we all know, we are speaking about the domain which is wireless medium. Okay, so when they tried to apply the simple CSMA for transmission and reception, this problem, hidden terminal problem, arises because we lies within the mutual range of both the neighbor nodes, where both are not aware about this. So a needless collision happens. So hidden terminal scenario is well explained with this four nodes. Okay, so whenever A is trying to send to B, at the same time if C tries to send to B also, since they both are not aware of each other's activity, a collision happens. This they call it as a needless collision, and this collision happens because mainly when we look at the root core, who is the cause now? The CSMA, because of the earlier simple protocol CSMA. Okay, and what is a next problem now? Exposed terminal problem. Say suppose B is within the mutual range of A and C. If B initiates the transmission, say suppose B wants to send a packet to A, theoretically speaking, and even within the range, when it applies CSMA, okay, A is idle, it is free to clear to send. Okay, whereas suppose C also wants the data to be transmitted, but not to B or to A. C wants to send a data to D. Now, theoretically speaking, we know that B is clear to send to A and C is also clear to send to D. But what happens now, since the neighboring node's activity is known or aware of it, say suppose B is trying to started a transmission and sending to A now. After a few seconds, C wants to send a data to D now. Since B is sending to A, when CSMA is applied by C, to its knowledge, it senses that some activity within this range is happening, within this C range is happening. So it thinks that medium is busy, so it doesn't send, thinking that collision may happen. So this is because happens to be a needless waiting. So only after B finishes its transmission, C starts sending the information to D. Here, collision won't happen, we know theoretically, but because of this simple protocol, C will think that the medium is busy, so I should not send. It'll be idle, which those idle time period we call it as a needless waiting time. So this problem, they call it, since exposed, the activity of B is exposed to both A and C, this problem arises. So hence we call this kind of problem in WSN as exposed terminal scenario or exposed station problem. Okay. So while building a protocol, media access control protocol, we have to keep in mind about all the four main scenarios we have spoken with respect to collisions, like because of overhead, because of trying to share at the same time, and because of hidden terminal problem, and because of exposed terminal problem. So we are going to build a protocol in such a way that it happens to be a collision resolution protocol. So what is the definition, actual definition for a collision? So actually speaking, what do you mean by a collision? Now, when multiple devices attempt to transmit data simultaneously over a shared medium, a collision happens. If a technique or uh, any protocols or algorithm has been designed to manage and resolve this collision, we call those protocols or algorithms to be collision resolution protocols. Here we people have built already the collision resolution protocol under MAC layer. Okay. So what is the solution? Basically, earlier they proposed two solutions for hidden node problem and exposed node problem together. What are they in? The first is busy tone solution, and the second one is RTS CTS handshake, and which is also used in IEEE 802.11. So this standard is followed by normal all the wireless communication networks, wherein here in this paper we are confined to wireless sensor network. So the standard for wireless sensor network is IEEE 802.15.4. The standard followed by uh, uh, wireless sensor networks are 802.15.4. Okay. So in earlier days and also in recent times, people are making use of these two solutions. What are they in a busy tone solution and RTS and CTS handshake? RTS and CTS together, this process comes under CSMA CA, that is carrier sense multiple access collision avoidance, because this is a answer for the collision. So earlier the process we learned, no, that they call it as CSMA CD, and this is CSMA CA. Okay. And also one more requirement we have to keep it in mind is we don't have a dedicated frequency bandwidth for wireless sensor networks. We make use of license free. So many of the wireless systems use the so-called ISM bands with the range of 2.4 gigahertz. So this also should be a constraint while designing wireless MAC protocols. So altogether, to be put under a summary of design goals of MAC protocols now, the first and foremost comes into picture is the operation of the protocol. Any protocol what we are going to design should be a distributed one. Okay, and the protocol should provide quality of service, support for real-time traffic. The access delay, which refers to the average delay experienced by any packet to get transmitted, must be kept low. Access delay should be low, simply speaking. The available bandwidth must be utilized efficiently. The protocol also should ensure fair allocation of bandwidth to nodes. Also, it should see to it the synchronization among the nodes. And it should control overhead. Also, it should minimize the effects of hidden and exposed terminal problems. The protocol must be scalable to large networks. It should have power control mechanisms, because as we all know, in WSN we are concerned about the energy saving. And finally comes the protocol should have mechanisms for adaptive data rate control, and also it should try to use directional antennas. So these are, so when people ask for what are the design goals of a MAC protocol, now we can list it here like as I've listed. So as a summary, these are the design goals of media access control protocol in wireless sensor networks. So the last point which I have stated, MAC protocol should be designed in such a way that it should use directional antenna. So any node deployed to any of the other neighbor nodes now, see to that we should make use of directional antennas so that it would be easier for any node to communicate to the neighbor node through the RTS and CTS. That is, RTS is nothing but whether I can send the data packets, because in CSMA what was the problem na? It just senses and it thinks that okay, the neighbor node is busy. Actually it is busy with somebody else, so it can send with some because in exposed terminal problem, that was though station was idle, we were thinking that it was busy. Okay, so those kind of exposed terminal problems could be resolved if RTS and CTS handshake is being used. What is RTS now? Before sending to anybody, in spite of checking the medium, you also you send a packet, request packet, asking that I'm going to send, shall I send it or not? So that packet we call it as a request to send packet. Say suppose this is a sender and this is a receiver, destination node. Now first it initiates RTS, and if this node is free, now it is very clear that it will state yes, I'm free to send. So that signal they call it as, that packet we call it as clear to send. So a first initial handshake has to be laid down, RTS and CTS. If both are laid down properly, RTS and send, and within the specified time, if I'm receiving a CTS now, then I can start transmitting the sensed information from that node to the next node. That we call it as a data. Okay, so this they call it as CSMA CA, simply speaking, in normal data communication networks, whereas in wireless sensor network they call it as a RTS CTS handshake. Okay, so this is a simple example with directional antennas we have shown here, having the source and destination node, how the packet transmission happens at 360-degree. Say suppose if two or more sensor nodes are deployed around, the same thing happens. Say suppose here a node and even that tries to send a request now. Say if this is initiated before this node now, then this will be assigned with, and this won't receive the clear to send packet. Okay, so thereby avoids a collision. And as an introduction, I would also like to propose the standards, the two standards used mainly for the wireless communication. Actually speaking, we could say that both are used for wireless communication, but this is mainly for general Wi-Fi connections, and this is for WSN and for ZigBee. So IEEE 802.11 is for Wi-Fi, and IEEE 802.15.4 is mainly for wireless sensor networks. So in what way both the standards differ based on certain features, we will look into it. We will run through fast. The main purpose of Wi-Fi standard is it provides high-speed wireless networking for data-intensive applications like internet browsing, video streaming, things like that. Wherein for WSN standard 802.15.4, low power, low data rate communication for WSN as well as for IoT applications. Here the frequency bandwidth is 2.4 GHz, 5, 6 also ranges to 6 GHz, wherein over here it is maintained less than 2.4 GHz, not more than that. As I told you, it is a license free. And the maximum data rate for Wi-Fi is 9.6 gigabits per second, wherein for this is 250 kilobits per second. Here the range, the transmission range is 70 to 100 meters for indoors and up to 300 meters for outdoors, wherein here 10 to 20 meters for indoors, and here theoretically speaking they have given 100 meters, but for 50 meters only practically speaking it tries to cover. Okay, so here the modulation technique used for Wi-Fi is OFDM, orthogonal frequency division multiplexing technique, to utilize the channel bandwidth effectively, so that we can accommodate multiple nodes at the same time. Here they make use of direct sequence spectrum and offset quadrature phase shift keying modulation technique for accommodate the different channels in a bandwidth. And when it comes to compatibility now with the earlier version, yes, it's compatible with the earlier versions, generally backward compatible within the similar protocols when it comes to WSN. Network topology, here for WSN we make use of only star, tree and mesh, wherein here ad hoc manner infrastructureless network also could be used, or sometimes with respect to access points now infrastructure mode is also used in wireless Wi-Fi. When it comes to power consumptions, Wi-Fi high power consumption, not ideal for battery powered devices, wherein here we all know we aim for very low power consumptions, ideal for battery powered devices. Here the security protocols is for wired equivalent privacy protocol being used, and for Wi-Fi Wi-Fi protected access version 2.3 is being used under 802.11. Where it comes to 802.154 is AES advanced encryption algorithm, whose bits are like 128 bit security is being used, and here 258 is also being used. Okay, latency, when it comes to Wi-Fi, low latency. When it comes to WSN, higher latency is being provided. When it comes the uses, typical use cases now, generally we make use of Wi-Fi standards mainly for high bandwidth applications like, as I've mentioned earlier, internet access, streaming, gaming and file transfer. For any home automation, smart controlling devices now, IoT devices, we go for WSN, and those are the users under 802.15.4. Network capacity now, when it comes to Wi-Fi, 200 plus devices per access point. Here 65,000 devices in a single network, Zigbee network. And interference accessibility now, here moderate, here very low. Okay, and channel bandwidth, here ranges from 20 megahertz, 40, 80, 160 for higher data rates, wherein here, as I've mentioned already, 2 megahertz for 2.4 gigahertz band, and sub bandwidth, it ranges from 600 kilohertz. Okay. Reliability, when it comes to the parameter reliability now, high reliability in environments with strong signal strength, mesh compatibility, mesh topology, simply speaking. Here high reliability in low power short range applications. Here also we prefer mesh networking when we opt for the parameter reliability. Okay, and typical deployment cost is here when it comes to Wi-Fi, moderate to high, depending on the access points and the routers and the infrastructure we lay down. When it comes to WSN, low, the cost is low, requires only minimal infrastructures, often embedded in devices, simple devices. So this is all about the comparison table between the Wi-Fi standard and Zigbee for the WSN standard. So as an outline, I could say that in today's video we have seen the challenges for media access control protocols, and the main challenge is the collision, and what are the two main problems we face: hidden terminal problem and exposed terminal problem because of CSMA, and the solution is CSMA CA, that is your RTS and CTS handshake, and a busy tone solution. Busy tone solution is nothing but whenever a sender node starts its transmission, mild radio wave tone would be blown, so that the neighbor nodes would be aware that the transmission is happening, but it is not that effective when compared to CSMA RTS CTS handshake. And also, as on whole, the whole summary of your design consideration we have seen, and the difference between the wireless standards, that is 802.11 and 802.14.5 we have seen. So the other protocols, we will enter into the protocols, the types of protocols in the next sessions. Thank you.